Next, we are going to learn how to divide a polynomial by another polynomial. Now, you cannot divide a polynomial by a polynomial the same way that you did by a monomial, okay? So I want to emphasize the difference between dividing by a monomial when there's only one term in the denominator versus when you're dividing by a polynomial when you have more than one term. Do you see in the bottom of the yellow highlighted denominator we have x minus 2. X minus 2, because there's two terms, the x is a term and the 2 is a term being split by a plus or minus sign, that means it's a polynomial and you cannot do it the same way. Okay? So when you're dividing by a monomial, the way we did it before is you just take the numerator and each of the numerators terms are going to be divided by the denominator. I'm not going to finish this problem, but this is how you did the problem before. You cannot do that when you're dividing by a polynomial. The x minus 2 is not a monomial. It is either a polynomial or a binomial. You must do something different, and the something different is called long division. And that's what we're going to be teaching you, how to divide a polynomial by a polynomial using long division. Now, there's some things that you need to remember from Math 0306 or pre-algebra or grade school from a long time ago. You may have had it then. And I don't want to insult your intelligence, but there's some specific things that you need to realize that are basically the same things. So we're going to be going over some very basic things so that I can help you understand how to do this basic process with numbers and apply it to polynomials, okay? So remember, if we have 32 divided by 4, that goes in evenly and the answer is just 8. There is no remainder on a problem like this, okay? I'm just trying to remind you that about remainders. Okay, but on the next problem, 35 divided by 4, it still goes in 8 times, but we have some leftovers, right? So 8 times 4 is 32. So we need to get all the way up to 35. So that leaves me with 3 leftovers out of 4. Or if you remember, maybe at one point you were allowed to write 8 R3, 8 remainder 3, but then we learned that instead of 8 remainder 3, it would be better if we had the 8 and 3/4. Now the way I pronounce that is 8 and 3/4. Okay, that and is really a plus. So another way of thinking about it would be 8 plus 3/4. So like if you're measuring 8 and 3/4 inches, you'd go 8 inches over and then another 3/4 and another plus another 3/4. Now when we're talking about numbers, we don't use this plus sign here, but when we use polynomials, we are going to need that plus sign in between the answer, which is the quotient, and the remainder, which would be the 3 over the 4. Okay, so that's just a reminder about what remainders are and what they actually mean. Now we're going to do a long division problem. 35 divided by 4,281. So I know you're like, I already did this, I know how to do this, this is long division. This isn't what we're learning today, but we want to really analyze this so that we can use the process on polynomials. So the first step when you are trying to divide something like this is you take 35 and you're trying to divide it into at least one of the numbers, one of the digits in 4,281. How many times does 35 fit into 4? Well, it doesn't fit into 4. So we're going to use 2 digits. How many times does 35 fit into 42? Well, it goes once. Now, when I'm saying how many times does 35 fit into, really what I'm asking is I'm asking you to divide 42 by 35 and get the whole number 1. Okay? Notice I'm only taking part of it. I'm taking the 42 and dividing it by 35, which we're going to call the divisor. Okay, so I'm only taking part of it and dividing by it. So that was step 1. Step 2, I take 1 times 35. 1 times 35 is 35, and then we put that up underneath the 42. Notice the columns are really important here, and the columns are going to be really important for polynomials as well. So the second step is what I did is I took the answer, the quotient that I got at the top, 1, and I multiplied. And I multiplied that back to the divisor. Okay, then after that, the step is subtract. So I'm going to write subtract on our next step. So 42 minus 35 gets you 7. All right, now I'm going to take that 8 and drop it and repeat the process. So step 4, I'm just going to say repeat or drop and repeat. Okay. All right, so I'm taking back to step 1, divide. I'm taking just the 78 and dividing it by 35. So 78 divided by 35 is 2. Step 2 says to multiply, so I take 2 times 35 and get 70. Step 3 says to subtract, so I subtract and get 8. Step 4 says drop and repeat, so I'm going to take the 1 and drop it, and now I have 81. And go back and repeat step 1 in red, divide. 81 divided by 35, so the 81 down here divided by the whole 35 is 2. 2 times 35 is 70. That was step 2. I should have done that in orange. 2 times 35 is 70. Step 3 says to subtract, and that gets us 11. Now there's nothing else to drop and repeat. In some cases we put decimals and we kept going, but we're not doing decimals with polynomials, but we can do fractions with polynomials. So the thing that you would do now is to write the 11 as the remainder over the original divisor, which is 35. So my answer is 122 and 11/35. Okay? But what that means with the word and is really plus 11 over 35, okay? When we're doing polynomial answers, you really are going to need that plus there. For example, a polynomial answer might look like x plus 3 plus 4 over the original divisor, whatever the original divisor is. This is just an example where the x plus 3 is kind of like the 122, and we call this the quotient. The 4 is the remainder, and that 4 remainder is like the 11 remainder. And then the x minus 1 is the original divisor, which is like the 35, which was the original divisor. So my steps were divide, multiply, subtract, and repeat. The steps are very similar for a polynomial, which is why I had you do this long division problem, which I'm not going to make you do one of these long division problems with numbers, for homework, but I am going to have you do it with polynomials. So here's your steps. Step 1, write using a long division part. Put the denominator out in front and the numerator inside, just like we had the 4,281 inside and the 35 outside. Step 2, divide the first term of the inside, the numerator, by the first term of the outside, the denominator. Remember, we have dividing the part by the divisor, okay? And put the quotient on top. So that was your red D divide step, right? So D for divide. Then step 3 says multiply the quotient by the term in front, which is the denominator or divisor, okay? That was your orange step, multiply. Step 4, it says change all signs and add down. In the subtract step, that was the blue subtract step. Subtract is really difficult when we have polynomials because people forget to distribute the negative all the way through. So instead of using the word subtract, what I'm going to write instead is I want you to change your sign. And essentially that's what we did. When we took the original 42 in the problem and we subtracted 35. I took the 35 in orange and I changed its sign. And I find that if students think of it as change your sign instead of subtract, that they get their answers correct more often because they will avoid making the mistake of not subtracting everything. And then our fifth step was repeat steps 2 through 4, which is that same repeat step that we had earlier. And then lastly is write the remainder as a numerator over the original denominator and add it to the quotient on top. So that was like the last step would be 122 and 11/35. So just how to finish it out. So I want to emphasize steps 2 through 5. DMCR. You really are going to need that, so I'm going to write this on the top of my problems, DMCR, so that you remember divide, multiply, change all signs, repeat. You can think of an acronym if you want, a sentence that might help you. If you let someone borrow your car, maybe you should say drive my car right. Okay. One of my students came up with this one semester and I liked it ever since. Drive my car right, DMCR. Divide, then multiply, change your signs, and repeat. So now we're going to try some examples.